What's up, YouTube gang? It's your boy JOSHABRAHAM. Yes, and just like the title is read, we are gonna do the exercise number 3. Number 3. Assignment number 3. It's just one page. Good lord. Mm-hmm. Pa, 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 spa, spit, pa, 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 skibit, skirrit, pa, 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 po. Top, 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 top. So where is this stupid ass, intelligent ass ChatGPT? You can't always keep on you can always you cannot always uh say bad things about ChatGPT. Sometimes this data fucker sometimes is just too useful. Did you see the wordplay I did? Oh man, I'm just too good at this. Uh, so this is my third assignment, and this is the first question I have to solve in my third assignment. What should I do, and what is this basically? Write a Python program that takes DNA sequence 5-3- from an output file. What? Did you just look at the word that literally starts with I? It did not start with O. It started with I. And did I just read output file? Oh man, am I hallucinating things? Huh? Fucking idiot. What what was that? It's input. Direction from an input file in the multi-FASTA format and computes the corresponding amino acid sequences they may encode. For simplicity, do not take splicing into account. You know what? That term is not registering in my head right now, but I did I have heard about the term splicing. To do so, perform the following steps for each DNA sequence. Check if the string is a valid DNA sequence. Perform transcription into an NR. Perform the transcription into an mRNA sequence. Consider the sequence from input file as template strands, and bear in mind in which direction transcription takes place. Perform transcript. I did this. I actually made a Python program that did this. So this should be easy for me. Perform translation into amino acid sequences, one letter notations by applying genetic code to all subsequences delimited by a start and stop codon in 5-3- direction. Group the above steps and functions with meaningful interfaces. The program should read all from the input file and write the DNA, mRNA, and amino acid sequences to an output file according to the supplied sample output.txt. Both files should be specified as command line arguments. Please adapt to the file name accordingly. So, what do you mean input file, output file? It's like the name of the input file and output file, because this is how the sample output file looks like. DNA sequence, RNA sequence, AA sequence. There's no triple A, it's double A sequence. So this assignment is asking you to write a Python program that takes DNA sequence from a file and converts them into mRNA, then translates them into amino acid. Say okay, I only did the converting to mRNA. Yeah, I did not do the translation part. and saves everything to an output file. You don't have to worry about things like splicing or introns, just basic transcription and translation. Understand the problem, read the DNA sequence from a file, multi-faster format, check that the sequences are valid, only A, T, C, G. Wait. Test sequence FA. Open with not Chimera X, nothing. I just gonna open with the text edit. Yeah, that's the file. Okay, that's the test to sequence. Check that the sequence are valid. Only AT GCG. I saw G. I saw T. I saw A. Yeah, nothing else. Nothing else. Nothing else. Damn, that's a lot of sequences. Okay. Um, Remember, if the DNA is a template strand, 5 dash, 3 dash to 5 dash, transcription creates an RNA sequence in 5 dash to 3. Remember, if the DNA is a template strand, the template strand is from 5 dash to 3 dash. Uh, so you're telling me that's 3 dash to 5 dash? Transcription creates an RNA sequence of 5 dash to 3 dash. Okay. Translate the mRNA into amino acid sequences, one letter codon using genetic code. Only translate from start codon to a stop codon. Is it mentioned? By applying genetic code determined by a start and stop codon. Save DNA, mRNA, amino acid sequence to an output file. Step 2. Plan your function. Your program should have functions with meaningful interfaces. For example, validate the DNA sequence. Return all base in for describe define transcribe DNA to RNA. DNA sequence. Return DNA sequence dot upper dot replace T and U, or T with U. Translation. Define translate RNA to protein. Genetic code equals AUG MUUUF UUCF. Full code needed. Protein sequence. Find the start codon. Translate all codons until stop codon. I mean, did they mention about what are the amino acids? Like, I don't know. If codon in UAA break file handling. Okay, I'm gonna give ChatGPT the file. Like, this is what they given me as. This is a sample output text they given me. Exactly, that's how it's gonna start the sentence. No, it's not gonna start perfect. Okay, okay. I did not predict GPT. In the midnight hour, in the shower, I don't mind the steam. I moved to do some things underneath the cover. Perfect, that's the sample output, tells us exactly how your program should format the output. Here's what it means. Sequence 1, just a label, increment for each sequence, DNA sequence, the raw DNA sequence on the file, RNA sequence of transpired mRNA, TTU, AA sequence of translated amino acid using genetic code, one letter codes. example, okay, I understood that, but my another doubt was this is basically showing that. So this is basically showing the proteins that are made from uh, that's um, then translated, and each letter specific amino acid. So how did you know which set of codons gives the amino acid specific amino? I also haven't seen anything mentioned in the question. The double A sequence shows the protein encoded by the DNA. Each letter is a one-letter code for amino acid. Example: methylbeta-alanine. Uh, each letter is yeah, amino acid. But how do you know which amino acid? Like it's a universal law. Just a minute. Devil's lettuce. What happened to the music? Clone Open Commander, ayo, what's up? This is the assignment. This is the new one. Check it out. I think this one's pretty easy from compared to the last time. Just a minute. Okay, I just had a message from my friend. Well. I was just checking out how this assignment's gonna look like, and it looks pretty good, I guess. Uh, DNA to RNA, DNA template strand. So if I understand, where is it? So this is 3 dash to 5 dash. RNA sequences is read in triplets called codons. Again, I think window size matters here, right? I could read the sequence based on window size and window size. Scold. So from what? How much can I use from last time's code? We got window size. That's really useful. Center letter, is that useful though? I don't think center letter is that useful, but window size is useful. We just replace. I think from the last program I wrote, the variable window size is gonna be useful here. Exactly, that's how it's gonna. Whoa. The window size from your dot plot program was used to decide how many letters to compare at a time. When plotting similarities in this assignment, transcription and translation work differently. You read the DNA sequence nucleotide by nucleotide to make it RNA. There's no sliding window. You convert the whole DNA sequence. You read the RNA 3 nucleotides at a time to map to amino acids. You can think of this group 3, but it's not the same as window size. Okay, it's always 3. Okay. Okay. Uh, this first sequence I got uh how do you write this 3 dash? No. Ugh. Okay, 3 dash to the way it's written in the FASTA file doesn't explicitly tell you the direction. It's just a string of nucleotides, usually. Oh, come on. Okay, by conversion. The question says DNA sequence in 5 dash, so you can treat the string as okay. So why did you say that? Why did you tell me that the template strand would be check if the string is a valid DNA sequence? No. Delete. Delete, 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 delete. BSA. Uh, up, 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 up. Jupyter notebook, or is .py better? I think .py is better, but Jupyter notebook has the markdown cell, which is really good in explaining. It's better to use .py. Okay. Whatever you say, ChatGPT. Whatever you say. Do we? Okay. EX. Okay. Mm-hmm. I gotta wash my hands. I gotta wash my hands. I believe it's gonna start with import sys because we are reading something from the system. Exactly. Please. Got him. Why is the input file like this? No idea, brother. No idea. Think, 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 think. God damn it. Yeah. If length of system argument is 3. Wow. Oh, 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 oh. That makes sense. That one makes sense. Okay. Import. Import. Eh? What's wrong with that? Yeah. Yeah, yeah, yeah. Hell yeah. There's still nothing. And if what? What happened there? Okay, import. Uh, if length len, yeah, len. Uh, okay. Do we got those? Yeah, we got those. You're telling me you don't need the space there? Okay. That was weird. And what else? Yeah. No. Tab down. Okay, okay. Got him. Got him. Do we need those? The double. No. So, at this point. Oh, bro, I'll get there. So at this point, I have named the input and output file from the command line. So these would be the command line are the command line arguments at the end. So how is the next step? I guess converting the DNA. I guess do we have to go for the complementary as this is phi dash 2, so we could just convert this to No. Oh, mRNA. Read. Now we're defining read faster. That's a new variable. Sequences with open file. With open file path RSF. Current header for line in F. Line. Not gonna lie, it's pretty fucked up. I'm thinking if the line starts with this thing, greater than symbol, then we could assign variable. And I do have my friend's code, right? Reference codes. Let me see how the reference codes are. Oh yeah. bounties. Oh, from Adam, import Adam. Want me to write the code for this one and send it to you like the last time? I mean, yeah, I would like to see, different perspective. Of course. Did you get the questions? Or did you already got the questions? Questions? Yeah, got it. Okay. I mean, yeah, I would like to see you try how you solve this. I don't know. It feels a. Now, what does this do exactly? Sequences in the dictionary. Oh, what? What does this actually do? From what I've seen, it's just gets the sequence according to their titles. But I don't know, maybe we could assign variable like j, and then if sequence each Represent what? Ding, ding, ding. Open the FASTA file. Current header. Variable to remember the current sequence. Current. Electricity. Not gonna lie, I'm pretty hungry right now. Should I go get something to eat? Current header. How it stores the sequence. Sequence in the dictionary. Mm-hmm. Sequences. This Oh, I still haven't kept my laptop to charge. Okay. What's with the two letters R and F? This is a built-in Python function that opens file. File path is the location of the fast file. R means read mode. You're telling Python, I just want to read the content of this file, not write anything on it. This part assigns the opened file object to the variable f. You can choose any name. It's common to use f for file. Later in code, use when you it's reading each line of the file. Okay. Wait. Sequence 1. That's how you write it in the output file. Let me clear my bladder. Just a minute. Damn, I got €5. Any pizza? Gotta get something to eat. God damn it. I'm hungry. I'm hungry. What do? I could cook. That's the most viable option. Cook? Yeah, I think that's the better option. Well, YouTube, I'm gonna end the stream because if I'm hungry, I'm not gonna be able to focus. So I'm gonna end the stream and we'll be continuing with starting the biochemical kinetics. Yeah, I just want to know what that assignment is gonna look like. I got an idea on this one. Now it's gonna be about that. I know this week was really bad, but we will get our shit together. Peace.